Hello everyone, greeting from Shriram College of Commerce and a very warm welcome to this session on artificial intelligence in business. I think we all believe that we are living in very interesting times. We are seeing some revolutionary things happening around us. We know people are using self-driving cars. We are getting our heartbeat information from our wristwatches. Our phones get unlocked by recognizing our faces. Our office attendance is automatically recorded by our fingerprints. We are talking with devices like Alexa and Google Home. Similarly, we are chatting with online customer service representatives, assuming as if we are chatting with some human being, although that may actually be a computer program. We are getting highly accurate tsunami or hurricane information much before they are due to occur. This list of these kind of revolutionary things can go on and on and on. This all is unbelievable. However, one question that comes to our mind by considering all very different kinds of examples is that what is making such revolutionary things possible? One of the biggest and common reason behind all these revolutionary things is a technology called artificial intelligence, which is popularly known as AI in short. AI has become a buzzword these days. Everybody is talking about it, and it is no longer an area of science or engineering which is trying to solve some crazy problems like playing chess. In fact, it has developed so much that it's able to contribute towards other areas in significant ways. And the field of business is also not left behind untouched. We are witnessing numerous AI-enabled products and services being rolled out in the market each day, and many more are there in the pipeline. It is high time that teachers and students of business are fully aware about the role of AI in knowing how businesses can be affected by it. For this purpose, in today's session, we would like to explore few key questions related to AI, like what is AI, what does it do, and how does it work? We would also explore questions like what opportunities are there for businesses and what are major issues associated with this. Okay, let's get started with the basic question of what is AI and what does it do? In simple terms, AI is a branch of computer science which enable computers in imitating intelligent human behavior and sometimes even surpassing that intelligence. Here we consider intelligent human behavior as the thoughts and acts demonstrated in a humane and rational manner. The human abilities like problem solving, visual perception, speech processing, understanding, reasoning, learning, listening, making judgments, etc., make up human behavior intelligent. While face detection can be considered an example of imitating humans' ability to recognize faces, but fingerprint identification is an example where computers have been able to surpass human intelligence because human beings are not good at recognizing people by looking at their fingerprints. In addition to this view of considering AI as an imitation for human intelligence, some people like to define AI as computers' ability to generate new knowledge from existing one, because intelligent human behavior, after all, relies on generating new knowledge from the existing data. In yet another terms, some people like to view AI as smart automation, because through AI, we are able to achieve automations of higher order. However, computer science defines AI as systems' ability to correctly interpret external data, to learn from such data, and to use those learning to achieve specific goals and tasks through flexible adaptation. Please note that this definition does not mention human abilities, rather stresses on the need for targeted incremental learning, because it believes that it is an essence or essential capability required for an effective AI system. The next important question that comes to our mind is, how does AI work? I guess our understanding about this question can be improved by knowing what is not AI or how AI systems differ from non-AI systems. AI is essentially used in problems where we do not have one defined way of solving a problem. There may be more than one possible solutions available. There might be uncertainties about various options. The available information might be incomplete, and there can be many more such reasons. Okay, let's take the example of driving a car. You know that at any given point in time, one has an option of choosing any of the possible directions, any of the possible speeds, depending on condition of the traffic and the roads. And it is not certain that only one way of maneuvering your car will be able to take you towards your desired destination. Successful driving depends on only two factors. One, the knowledge of driving rules, and second, ability to decide which next action is to be taken at a given point in time. For example, applying brake or pressing accelerator, turning left or turning right, and so on. Now on the other side, in case of a non-AI problem, like calculating income tax of a person, one can follow a series of well-defined steps and finally calculate the income tax amount. So one can say that AI systems behave in a reactive manner to the given state of the environment in order to achieve their goals. To dig this deeper, let us understand the basic flow of information in an AI system. An AI system takes its input from its environment. These inputs are called as percepts. Using these percepts, the AI system takes a decision on the basis of some kind of a logic, which actually is the biggest puzzle in this game. The decision is then passed on to actuator, which takes the desired action. Now, with regards to the logic part of AI system, at an abstract level, AI uses two fundamental approaches. The first approach is called rule-based approach, and the second one is called data-driven or learning-based approach. In rule-based approach, AI systems are hard-coded with rules that are used in solving a problem. Contrary to this, in data-driven approach, AI systems are not given any rules. Rather, AI systems are given many examples and ways to learn rules from the data automatically. An intuitive example to understand this difference is how we learn languages. We all know that a language can be learned in two basic ways. One, by using a grammar book, and two, by observing people who are using that language. We all have learnt our native languages by observing people around us speaking that language, while we have learnt other languages using books. To make it even more clearer, let us look at an abstract example of moving goods from one place to another in a grid of cities. For the sake of simplicity, let's assume that these cities are placed on a 3 by 3 grid of structure. Now, in order to move goods from one city to another, as shown in the picture, we want our computer to find out a route. One way to solve this problem is that we provide only the rules of possible maneuvering of AI system. That is, in case of corner cities, the movement can be done only in two possible directions, while for cities in the middle, the goods can be moved in all directions. Now, after feeding these rules, we can let the computer try different moves and ultimately reach to its destination after carrying out a series of right as well as wrong moves. This way, we ultimately find the solution of our problem. This kind of logic is called rule-based AI. Now, if an AI system is shown many examples in which goods have been successfully or unsuccessfully moved from one city to another, an AI system learns which movements are better than the other movements. This would be called as learner-based AI. Please see in the diagram that after training, the data-driven AI system has learned some weights for different movements. The weights suggest the AI system as to which directions the AI system should try first in order to reach to its destination in faster time or lesser cost. Although this rule-based approach is very effective in many circumstances, data-driven approach is highly attractive as it can learn the things on its own and therefore can change its learning as the new data shows up. The data-driven approach is limited only by the possibility of what best can be learned from the data. But if the data is exhaustive, a data-driven system is expected to capture all the relevant rules. The data-driven approach is found to be so powerful that it is being said that the penicillin drug, which was discovered after rigorous research of 15 years, could have been discovered in a shorter period if AI would have been present during those times. On the similar lines, one can also say that Einstein's equation of E is equal to mc square could also have been found out by an AI machine rather than Einstein. Further understanding about the working of AI can be done by understanding about various concepts or terms which make AI possible. These concepts include machine learning and its various types as classification, clustering, associative mapping, and numeric predictions. Other related concepts are regression analysis, recommender systems or collaborative filtering, natural language processing, sentiment analysis, neural networks, deep learning, big data, Internet of Things, and many more. We will try to describe some of these concepts in today's session. First of all, let's talk about machine learning, as it is the heart of data-driven AI. Machine learning refers to computational methods that learn from examples. We have observed that in this way, more accurate and useful rules are found out, which leads to improved performance and accurate predictions. Machine learning can be applied in three different ways. In the form of supervised learning, where the data values are available with their labels. The second form is unsupervised learning, where data is not available with any label information. And the third form is reinforcement learning, where learning is done incrementally so that learning is improved as the new series of data are processed. Machine learning objectives can roughly be divided into four distinct types: classification, clustering, associative learning, and numerical prediction. Under classification, ML tries to identify the given data into predefined classes or categories. For example, a classification ML may identify a customer as a genuine customer or a window shopper. Under clustering, ML tries to divide the data items into undefined classes. For example, a clustering ML may divide the group of customers into segments whose definitions are not already known to us. Under associative learning, ML tries to learn associations amongst data items. For example, from the sales records of a store, ML may identify a strong association between nappies and beer, while this may not be obvious to us. Under numerical prediction, ML tries to come up with numerical values as prediction results. For example, ML may forecast demand of cars for the coming year in the form of some number, for example 14,000 cars. For these ML objectives of classification, clustering, association learning, and numerical prediction, ML may use different techniques. Some of these techniques are linear regression, logistic regression, k-nearest neighbor algorithm, k-means algorithm, decision trees, neural networks, and so on. To give you a sense of how ML learns from the data, we will take the example of k-means algorithm. This algorithm is very easy to understand. Let's assume that we have customers' income information and we want to divide them into 3 segments, but do not know how to define these segments. We believe that the segments should be such that they have greater similarity within each segment but have got greater disparity between different segments. K-means algorithm follows 4 essential steps. In the first step, let us assume any 3 random customer income values as mean values of the required segments. Let us call these mean values as centroids. In step 2, we associate or link each of the remaining income values to their closest centroid. This would give 3 groups of income values represented by 3 centroids. In step 3, we find the mean of the income values of each of these segments and consider them as new centroid. This step brings the centroid towards the center of the cluster of income values. In step 4, we reallocate all the remaining income values to the new centroids found in the previous step. This way, we will redefine the groups of income values such that the income values with each group are closer to each other. Here, being more closer means more similar to each other. We repeat the earlier steps till the time the new found centroids are not very much different from previous found centroids. Once the procedure is over, we find 3 groups of income values which are closest to each other within one group and farthest from the other groups. Now, finding the range of income within each group will give us the required segment information. In this algorithm, what we see is that the centroids keep shifting after each iteration and the groups start becoming more and more cohesive. Now we would like to take one more example that is highly used in online businesses. Let us understand the working of recommender systems. This system uses underlying assumption that a customer is likely to choose the same things in future that others have chosen in the past, provided the customer past history of purchases matches with the past history of the purchases of the others. So, ML learns from the preferences of a large number of customers and then applies that learning for any new customer under the assumption that the new customer preferences patterns match with the preference patterns of the old customers. This approach is also called as collaborative filtering, where collaboration refers to the learning from the opinion of similar customers and filtering refers to using it for the individual customer. To understand it, suppose in a movie store, many customers in the past have ordered a sci-fi movie named Avatar and also a historical movie named Lincoln. ML understands this association, and now if a new customer orders the movie Avatar, the recommender system will be able to propose the movie Lincoln, assuming that the new customer will have same preference like others had. After knowing about how machine learning works, let us discuss another important concept in AI called neural networks. Neural network is a collection of nodes that behave similar to how neurons function in our brains. The data goes from one layer of neurons to the next layer of neurons. Each layer transforms the data in some way. The use of neural network provides the associative learning type of machine learning, where we want to find out some mathematical transformation logic that could convert input to desired output. Neural networks use learning rather than programming. The good thing about neural networks is that they can handle complex interactions which are too difficult to model, such as inferential statistics, and programming logic. The use of neural networks is the reason behind AI systems of speech recognition and language translation like Google Home, Alexa, Siri, and Google Translate. The Grammarly application that we use these days for correcting grammatical and writing errors in our documents is also an example of an AI system trained on neural networks. An extension of neural networks that is a very popular concept in AI is deep learning. Deep learning refers to neural networks that have high number of hidden layers. Deep learning systems are trained over very large data sets and for long time durations. Another successful area in which AI has contributed significantly is natural language processing. This refers to computers' ability to process natural language like humans use in their conversations. NLP relies on various technologies like morphological parsing, in which a sentence is broken down into various components for understanding the meaning of each word and the sentence as a whole. More recently, NLP has started using a technology called n-grams, in which it computes probabilities of finding a word after a sequence of n words from a very large data set of millions of sentences. These probabilities suggest which word should come after which word sequences. For example, n-gram computes the probability of finding the word goes after the word he, and probability of the word go after the word he. The n-gram will suggest that the probability of finding the word goes after he is more than the probability of finding the word go after he. And an AI system will be able to find out if the word sequence he goes is correct and the word sequence he go is not correct. Opinion mining or sentiment analysis is a part of NLP which tries to evaluate the sentiment value in a given text. For example, using sentiment analysis, a company can know how many customers are satisfied with the product from millions of reviews about the product on the social media posts. For this, AI system essentially use a simple approach of finding the frequency of positive words like good, satisfied, wonderful, like it, etc. in the given text. However, the task of sentimental analysis becomes very complex as it has to resolve many ambiguous texts where the sentiment is not negative in spite of the fact that there are negative words present in the text. Text processing, which is a part of NLP, has also enabled question-answer AI systems called chatbots, with which a customer can interact to get its problem solved. AI has revolutionized the human-computer interface through the conversational agents, which can listen and speak in natural language. People are now able to interact with machines as if they are talking to an individual. Another reason that is making AI effective is big data. In context of AI, big data refers to huge amount of data that can be processed by AI system to gain the required learning. Big data refers to the data which is very large and sometimes is being generated at an unprecedented speed, like Twitter posts, social media content, YouTube videos, Instagram pics, customer transactions records, data streams coming from surveillance systems, data coming from IoT devices, and so on. AI requires special tools like Hadoop, etc. in order to process such high volume of data. This also brings an important player associated with AI named Internet of Things. IoT refers to objects that are equipped with some intelligent capability and serve as an input source for AI learning systems. So far, we have tried to understand how AI works in various fields and how different concepts and technologies are associated with it. We now shift our focus to find the opportunities exploited or possible in the field of business. It is believed that businesses get a boost in effectiveness and efficiency if they are able to have better understanding of customers. The conventional practice of understanding customers is done through customer segmentation, for which we just now found out that ML is able to create more accurate segments. The performance of customer relationship management or maintenance systems, CRM, can be greatly enhanced by using the segmentation done as per the customer's state in the customer's life cycle. Personalized marketing has been a dream for marketing departments who want to know which marketing message or method will be suitable for a particular customer. AI through recommender systems has helped many organizations in providing possible recommendations that a customer may likely be interested in. Organizations like Amazon, Netflix have gained strategic lead due to their personalized marketing systems. Recommender systems have also proved to be beneficial for online businesses in increasing customer retention, which otherwise is considered to be a major challenge in online space. With regards to HR, AI is improving the hiring process by knowing what could be the optimum time to hire, or by identifying which could be suitable candidates for hire by doing their performance and personality profiling using online information. HR system can also raise alarms about possible unsuitable candidates and people who are likely to leave the organization. For a long period of time, AI has been helping financial services in finding differences in usage patterns of genuine transactions and possible fraudulent transactions. AI is also helping supply chain management systems in making more accurate demand forecasts. The demand predictions done by using AI techniques of neural networks have proven to be more accurate than the predictions made by the conventional time series analysis. AI has also made it possible to predict demand at different levels of the organization, for example, at organization level, regional level, unit level, or product level. With regards to production processes, AI is not only helping in estimating the expected failure and downtimes, but also possible reasons for those failures and downtimes, and thus improving the efficiency of production. With respect to research and development, AI is greatly helping in creating new products. In pharmaceutical industry, many drugs are being found out by using AI techniques. In medical diagnosis, AI techniques are helping in detecting future ailments well in advance. In logistics and travel too, AI is helping finding possible problems in moving goods on certain routes and suggest alternative routes, just like Google Maps is helping individuals for providing congestion information on different routes. Many organizations are employing automated voice response systems which are able to solve most of the customer queries through AI customer systems, and not by employing human beings. In case any query is not being able to be processed by AI system, that may be redirected to human agents. This way, organizations are able to reduce customer service workforce. It is also important to realize that in most of these applications, AI systems are involved in predicting some kind of information about a situation. This suggests that AI is not a definite science, but an approximate science. It may be possible that sometimes its predictions do not come out to be true. However, with high degree of accuracy, approximate systems can be trusted reliably. Now, after discussing about what is AI, how does it work, and how it is being used in various aspects of businesses, we would like to find out if everything is okay with AI. in spite of so many impressive features of AI, all is not okay with AI. We have many issues of concerns in the form of disadvantages, limitations, ethical issues, possible misuses, threat to livelihood, and threat to human existence, etc., etc. With respect to limitations of AI, we know that AI learns from data and hence is as good as the data can make it. At the same time, AI is also dependent on underlying mathematical models used and computational power of machines. There are still numerous problems which require exceptionally high computational power than what is available to us. With respect to the misuse of AI, it is possible that results of AI are not used with fair intentions. Cases have been seen where cab services are choosing longer routes to indicate or increase their revenues, although their systems are able to find out better and shorter routes. Similarly, cases have also been found out where cab companies report different amount to a customer and different amount to the cab driver to save on their commissions. There are also some ethical issues with it. AI requires enormous amount of data. The data may be captured by web stores while customer is selecting a product, surfing through the websites, clicking on the product, or providing her interest while filling a social networking registration form. This is a crucial data as it governs the private life of individuals. Should this data be stored, captured, and used for sale of products, maybe even sold to other parties, is a question of concern. We do not have suitable rules and regulations that govern the use of development of AI systems. People may use technology to design machines that intrude into the boundaries of a country and drop bombs at their command. We know drones are being used exactly in the same way. Since AI can store enormous amount of data, has longevity and scalability, there is a fear that one day human beings will be replaced by AI. However, in near future, the issue of concern is whether AI will eat up people's job and make them redundant. Examples of manless organizations are becoming real. Many of such concerns have already been raised by Elon Musk and Stephen Hawking. Maybe the answer lies in whether technologists, AI adopters, and governments are listening to such concerns and making sure that such negative repercussions do not take place. While concluding this session, I would like to mention that all kinds of businesses are looking for ways of making constant improvements and innovation, and artificial intelligence is a gateway for the same, irrespective of the issues related to it. Businesses can adopt AI not only for making their product or service development, logistics, processes, marketing, sales, customer support much smarter, but also acquiring strategic advantage if possible. The students and practitioners of business are expected to understand AI and come up with new ways of leveraging this new technology. We believe that while on the way of exploiting the benefits of AI, we will be able to find ways to balance its negative aspects as well. Thank you.